All right, my friend, let's work through this beautiful circle geometry problem together very carefully. Because there are two very important ideas hiding inside this question. One is the Pythagorean Theorem, and the other is the Intersecting Chords Theorem. If we connect those two ideas correctly, finding the radius becomes surprisingly straightforward. So, let's begin. We are given a circle containing an isosceles triangle PQR. The two equal sides are PQ equals 13 units and PR equals 13 units, while the base QR equals 10 units. Our target is to find the radius of the circle. Now let's look at the triangle first. Since PQ and PR are equal, this is an isosceles triangle. A very useful property of an isosceles triangle is that if we draw a perpendicular from the top vertex down to the base, that perpendicular also bisects the base into two equal parts. So, let's draw a perpendicular from point P to side QR and let the foot of that perpendicular be point M. Notice what happens here. Since QR equals 10 units, and point M is the midpoint of QR, we immediately get QM equals MR equals 5 units. Now, before we continue, if you're enjoying these step-by-step geometry explanations, make sure you like this video and subscribe to the channel because we solve many interesting problems, exactly like this one. Now, let's focus on right triangle PQM. We know that PQ equals 13 units and QM equals 5 units. We want to find the length of PM. The reason this is important is because PM lies on the diameter that we will eventually use to find the radius. Since triangle PQM is a right triangle, we can apply the Pythagorean theorem. Remember, the Pythagorean theorem tells us that in any right triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. In our triangle, the hypotenuse is PQ. Therefore, we can write PQ squared equals QM squared plus PM squared. Now let's substitute the known values. PQ is 13. So we get 13 squared equals 5 squared plus PM squared. 13 squared is 169 and 5 squared is 25. Therefore, we have 169 equals 25 plus PM squared. To isolate PM squared, subtract 25 from both sides. 169 minus 25 equals 144. Therefore, PM squared equals 144. Taking the square root of both sides gives us PM equals 12. So we have found that the altitude PM is 12 units long. That's a very important result, so keep that in mind. Now, let's move to the next step. We extend the line segment PM downward until it meets the circle again at a point which we'll call S. Notice something very important here. Because PM is the perpendicular bisector of the chord QR, it passes through the center of the circle. Let us call the center O. Since the line from P through O continues to S and passes through the center, the segment PS is actually a diameter of the circle. And once we know the diameter, finding the radius will be easy because the radius is simply half of the diameter. So now our goal is to determine the full length of PS. We already know that PM equals 12. Therefore, we only need to find MS. To find MS, we are going to use the Intersecting Chords Theorem. Let's look at this step carefully. The theorem states that if two chords intersect inside a circle, then the product of the two segments of one chord equals the product of the two segments of the other chord. In our figure, chord PS intersects chord QR at point M. Therefore, the theorem gives us PM multiplied by MS equals QM multiplied by MR. Now let's substitute the values we already know. PM is 12, QM is 5, and MR is also 5. So we get 12 multiplied by MS equals 5 multiplied by 5. 5 multiplied by 5 equals 25. Therefore, 12 multiplied by MS equals 25. To find MS, divide both sides by 12. This gives us MS equals 25 divided by 12. Excellent. Now we know both parts of the diameter. The upper part, PM, is 12 units, and the lower part, MS, is 25 over 12 units. Therefore, the entire diameter PS equals PM plus MS. Substituting the values, we get PS equals 12 plus 25 over 12. To add these numbers, we first express 12 with a denominator of 12. 12 can be written as 144 over 12. Therefore, PS equals 144 over 12 plus 25 over 12. Since the denominators are the same, we simply add the numerators. 144 plus 25 equals 169. So the diameter PS equals 169 over 12 units. Now we're almost done. Remember that the radius of a circle is exactly 1/2 of the diameter. Therefore, the radius r equals 169 over 12 divided by 2. Dividing by 2 is the same as multiplying by 1/2, so we get r equals 169 over 12 multiplied by 1/2. Multiplying the denominators gives 24. Therefore, the radius equals 169 over 24 units. If we convert that fraction into a decimal, we get approximately 7.042 units. So our final answer is that the radius of the circle is 169 over 24 units, or approximately 7.042 units. Notice how elegantly everything came together. First, we used the symmetry of the isosceles triangle to split the base into 2 equal parts. Then, we applied the Pythagorean Theorem to find the altitude. After that, we used the Intersecting Chords Theorem to determine the missing segment of the diameter. Finally, we added the 2 pieces of the diameter and divided by 2 to obtain the radius. This is a wonderful example of how different geometry concepts work together to solve a problem that initially looks difficult. And my friend, if this explanation's helped you understand the logic behind the solution, don't forget to like the video and subscribe to the channel and leave a comment telling me whether you solved it before reaching the final answer. Thank you for learning with me, and I'll see you in the next interesting geometry challenge.